Next up on our agenda, we have Alan Cudmore of NASA Goddard presenting a demonstration of deploying NASA's core flight system on the RTEMS real-time operating system. Confluence of quite a number of our topics today. So Alan, it's all yours.
Okay, thanks. Let me share my screen here. See if I can get through this in 25 minutes. Should be possible. Okay, so my name's Alan Cudmore, and I'm here to show you a CFS demo running RTEMS on the BeagleBone Black. So I'm going to really skip this agenda just to save a little bit of time here. So what are my goals for this demonstration? I want to demonstrate one way to build and run the CFS on an inexpensive real RTEMS target board. Of course, there's going to be more than one way to do anything and run CFS on different targets. And so I'm just going to show you one possible way, not necessarily the right way. I want to discuss different ways that I approach the CFS board to this board, and also give you a quick view of the modifications that you need to adopt the CFS, the bundle, to a new target like the BeagleBone Black running RTEMS. And of course, all this code is available for you to look at and use. And the last goal I had was I really wanted to make this demo reproducible. I wanted to be able to come back to this demo and these slides like years from now and hopefully be able to reproduce it. Okay, a little bit about the hardware. I'm not going to read all of this. You can look online and get all these specs. And of course, these slides will be available just using this BeagleBone Black computer. It's a little single board computer that typically runs Linux. And it costs like $55 US. And the key thing for me was I wanted something that ran RTEMS and had network support for my demo. And this definitely met those requirements here. Talking about the software that I'm using, of course, we have the boot artifacts, the U-boot bootloader, the device trees, and the second stage bootloader. They sit on the SD card or alternatively in the flash on the board. I'm using RTEMS 6.x, the current development branch. And I'm using the RTEMS BSD library. That's for my network interface. I'm using something called an RTEMS kernel image project. And this is something, if you've ever done VxWorks development, one of the first things you do when you bring up a new board is you build this VxWorks kernel image. I think now in VxWorks 7, it's called the VxWorks image project. And so I have a project I've been dragging around for years for my RTEMS work that's very similar to that VxWorks kernel image. And then last but not least, we have the CFS bundle, which is the open source bundle. And it doesn't include all of the apps that we use. It really just has the OSAL, PSP, CFE core, and just a collection of real test apps that really get you started. So that's what I'm going to be demonstrating. Okay, so taking a look at some of the options for this CFS port to RTEMS. So the first choice I kind of ran into was, what RTEMS version do I want to use? We have experience with RTEMS 4.10 on some of our flight missions. We're using RTEMS 5 on some of the current missions we're developing. But I wanted to use RTEMS 6, the latest development branch, to give me a little bit more experience with it. And there's a couple of targets that I'm really interested in using in RTEMS 6, like the microblaze and 64-bit ARM. So that's really why I chose 6. Also, the next option I was looking at was, do I want to load the CFE core as a module where it's dynamically loaded from the file system? And that's typically what we do with VxWorks or even our current RTEMS projects that we're using the CFS on. We'll take the CFE core, which will be kind of one object module, and we'll load it dynamically from the file system when we boot. But I guess another option is you can just link the CFE core with your RTEMS image and just kind of boot it all together. And in this case, and actually I originally intended to dynamically load the CFE core from the file system, but I was having a little bit of trouble with the dynamic loader on the ARM architecture on RTEMS. So I decided just at the last minute to kind of link it all together. Another related option is, do I want to load the CFS apps from a file system dynamically, or do I want to link them all together with the CFE core? And in this case, I was able to load the CFS apps from the file system. Something about the size of the modules that I'm using, the apps are all very small and simple, but they seem to load fine with the dynamic loader. So you can go, pick anything your mission really needs. You can link everything together, like your OS image, CFE core, and all of your apps, and you won't use any kind of symbol table facilities or dynamic loader, or you can dynamically load everything. In this case, it's kind of a mixture. Okay, a couple of other options I had to look at. So I had to look at, okay, what file system am I going to load some of these files from? I can use the DOS file system on the SD card on the BeagleBone. Using the BSD library and the support for the devices on the board, I could have mounted that file system under RTEMS and used it. I could have also tried to develop some sort of way of mounting the eMMC flash file system in the BeagleBone. Right now, I think there's a Linux kernel loaded on there too, but I generally just boot from the SD card when I'm using RTEMS. And the third option, which I picked, was use the RTEMS in-memory file system plus a tar file feature. And that's a really neat feature that lets you preload files onto a tar file, and then you can just kind of load the image into RAM. And when you start up RTEMS, you can make a call that just kind of unpacks all those files onto your in-memory file system. And so that's where all of my CFS applications, tables, and my startup script are going to be located. And that really makes this portable to other RTEMS targets too. It's really nice when you're bringing up a system and you don't have like a flash driver written or haven't picked your file system. You can actually get files onto your target. It's very similar to like a Linux initial RAM disk image or even the VxWorks ROM file system. And finally, I wanted to take a look at the network options I had. And of course, for this demo, I really wanted network capability. So with RTEMS 6, the network stack is really not included in the base kernel. So you have no network, which obviously we use on most of our flight missions right now. You could use the RTEMS legacy network stack. You can use now the lightweight IP stack, or the option I picked, which is the RTEMS BSD network stack. And again, I picked it because it works on the target I picked. I wanted to kind of have the path of least resistance and something that anybody else could pick up and use if they have a BeagleBone. Okay, just a little bit about the development environment I'm using. So I'm using a Docker-based development environment for this demo. My Docker image has the RTEMS cross compiler, BeagleBone Black BSP, and the live BSD libraries for the BeagleBone, all compiled and ready for me to use, essentially like an SDK. And I'm using specific Git commit tags to keep the demo from breaking in the future. And we'll see if that actually works, but I'm hoping. And then the next thing is my RTEMS kernel image project, which I mentioned before. That gives me all of my startup code, sets up my file systems, network, and all that good stuff. And finally, we have the CFS bundle, which I'm using kind of the latest and greatest there, which is the Calum release, or it's the current development branch, plus a few modifications. Now, it's important to note that I didn't modify anything in the portable CFE code. I really just provided the platform layer pieces that were needed. And I'll take a very quick look through some of this code and show you just how simple it really is if you're just being really generic. Okay, so next we're going to take a look at these changes. As you can see here, I have this all in a GitHub repository. these slides will be available, and I can always post the link in the Slack too, so don't worry about missing it. But what I have is I have the OSAL kind of layer shim, which is called the OSAL board support package. In this case, I made one called generic RTEMS. And then I have a new platform support package, also called generic RTEMS. I had to make a new CMake platform file. It's called rtems6.cmake. And really, that's very close to what's already there, just one slightly different option. And then last, I had to make the toolchain file. And I really think you could probably run this on multiple targets just by changing the toolchain file in this case. So actually, I'm going to bring up my web browser here and show you a few of these options or a few of these source changes. So this is my repository here. Hopefully it's legible enough. You know, I have my Docker scripts and Docker files that I used. I'm not going to go into too much detail here, but I've kind of layered this Docker image where I start with some basic tools, add the ARM cross compiler for RTEMS, add the BeagleBone BSP, and then finally add the live BSP. And so I have a bunch of RTEMS Docker images like this for different architectures and different BSPs. And I'm just using this particular one. And then here's my RTEMS kernel image file or directory. And it just has some simple startup code in it and a bunch of other demos that I kind of packed in there. And it actually has some startup code for the CFS. And then finally, we have the CFS. And some of the changes I have include, let's see here, I have the OSAL BSP. And it's really, instead of PC RTEMS, I now just have this one called generic RTEMS. And it really is just real bare bones basic code here. Not much to it at all. And unfortunately, I can't spend a lot of time going through it, but you'll have the code, so you can just feel free to look at it on your own time and feel free to ask any questions about it. You know, moving over to the PSP, we have the generic RTEMS PSP as well. And that's so simple. I mean, it really doesn't have any real hardware specific code in it. And I guess that's another point I would like to make too, is that while I provided this generic RTEMS PSP, if you're trying to do a flight PSP, there's a lot more work you really need to do. This is just like kind of a bare bones skeleton. And that's kind of the nice thing about the porting layer in the CFS is you can get 90% of your applications up and running with just a bare minimum skeleton PSP, just enough to kind of bootstrap everything. So it's kind of nice to get that done early, hand it over to the application developers, and they can do a lot of work while you're going back and filling in all the details. Okay, and finally, you know, we have this CMake platform file. And one of the big differences between what I have and what's already in the CFS repository is just the way things are linked. The way the reference RTEMS system in the CFS repository is, it's really geared towards the PC or the x86 BSP, and it's designed to run in our continuous integration system. And so it links everything together with RTEMS as one big executable, and it has some platform specific stuff in the PSP and the toolchain file. Mine just, it's a lot closer to the VxWorks CMake platform file, where basically it's just building the CFE core as just an unlinked object that you can either dynamically load, or in my case, I'm actually linking it to my RTEMS kernel image. So let me try to keep pace here and start building some things. So what I have here on my Windows 10 machine is, this is just your average Windows PowerShell, but I am using Windows Subsystem for Linux and Docker. So I'm in my Windows Subsystem for Linux shell, and I have Docker Desktop installed, and I have my repository checked out here, all ready to go. So I need to build the CFS first, but I don't have a compiler here on Windows Subsystem for Linux, so I have to run my Docker my Docker image that has the tools in it. So to do that, I just run this script here that runs my Docker image. So now I'm in the image. I can go into the host directory because I'm going back into the Linux, the host Linux system where my repository is to actually build it. So now I'll switch into the CFS directory. And if you look in the BBB defs directory instead of sample defs, that's where my toolchain file is and some of the definitions that I've set up. So let's take a look in there. And let's see, yeah, here's my toolchain file. It's ARM BBB RTEMS 6. So let's build it. So I'll have to type make simulation equals ARM BBB RTEMS 6. Right. And this sets up all the CMake magic. So then I just type make, and it does the cross compilation with the RTEMS compiler. And this is building the OSAL, PSP, CFE core, and all the apps, like the sample apps that I've included. So everything's built. So now I need to install it. And of course, I could have just done make install on that very first line, and it would have done everything. So now we have this installed. And let's take a look at where it is. It's in the build directory in exe CPU1. And so what we have here is we have the kind of the CFE core and then this non-volatile directory that I created. We have all the apps and the tables and a startup script. So everything's kind of ready to use. But now we have to kind of connect it to RTEMS. You know, they're just object files sitting there. Let me go back to my host directory here, and I'll go into the RKI2, and I need to build that. So I have a build directory here, and I don't know if it's that easy to see, but there's two targets here. One is called BBB, stands for BeagleBone Black, Live BSD. And you can build a standalone image without the CFS of this RTEMS kernel image with that target. The other one includes the CFS, so that's what we're going to build. So live BSD, oops, CFS. And it's going to assume that the CFS has already been built. I would love to connect all this with CMake, but I just haven't done that yet. This uses an old-fashioned make file. Okay, so let's just build it. We just have to type make. And so this builds everything that was in that RTEMS kernel image. It bundles up all the CFS files. It actually links the CFE core as part of the final executable, and it spits out my final image that I need. And that final image is a bootable image for U-boot called RTEMS RKI.image. So now I'm going to get out of my Docker image here, my running container, and I need to get this over so I can use it in Windows, or I need to get it on my SD card, right? So we can actually run it. Let's see, I have enough time. So let's see, I need to go back into the RKI2 directory, build. There's my image. And since I'm in the Windows subsystem for Linux, you can actually copy things over to your actual, the Windows part of your system. So I can copy RTEMS, RKI.image to mount C. That gets me to my Windows C drive, users, in this case, Alan, desktop, and you'll see it show up right here in my desktop. So that's the image. So now we have the image, we're done building, so we actually need to run it. So here's a serial monitor I have, and here's the board. I have another webcam pointing at the board. Let me see if everybody can see this correctly. So this is just a serial monitor that's hooked up to the serial port through this cable here on the BeagleBone. And what I need to do next is I need to install the image. So I'll borrow the SD card from India here. My Lego Indiana Jones was providing me with a size reference for the board. And I have to pop it into my PC here and copy this image over. So it's complaining about the Linux thing here. So now down here, drive F, you can see all the artifacts that boot the board. And we need to copy the image we built over to the SD card, replace it. And now we can eject it and just plop it into the BeagleBone. So I got to put it in the little SD card slot here, the micro SD card actually. And then I can power this thing up. Now, every once in a blue moon when I'm testing this, it'll for some reason decide to boot Linux from the onboard flash instead of my SD card. So hopefully that won't do that here. And looks like it's booting RTEMS. And so RTEMS is coming up here. And you can see that it's up. And there's a few things that the live BSD stuff complains about, like when it's setting up the network address. I'm really not too sure how to get rid of some of these messages, but I can talk to Joel about that. Okay, so here we are, we're running RTEMS. So I'm going to give you a real quick tour of what's going on here. In the shell, there's a lot of different commands, and you can add a lot of commands. Like there's things like you can look at what tasks you're running. And if you notice here, a lot of these tasks are related to the BSD stack. There really aren't too many things running in RTEMS. You can take a look at, hopefully my IP address is set up correctly. Fig, and yep, I can see that I do have a Ethernet address or an IP address for my Ethernet device set up on the local network here. Okay, so that's obviously going to be very helpful for commanding the system. I can do things like these little things like a task demo here. This task demo started 5 tasks.
2-minute warning, Alan.
2 minutes? Okay. All right. Well, let's just start the CFS. Okay. So we started up the CFS, and you can see that it loaded everything. It went through the files and the startup script and loaded all of my files. You can see here in the non-volatile disk where they were all stored in the RAM disk. Okay, so now I'm just going to skip right ahead and try to send a command or two. So I have my little CFS ground system. Let me see, I gotta get this thing out of the way here. And let's send like a no-op. And we actually have to tell it which system we're sending it to or which IP address we're sending it to. So 192.168.0.231. And I can send a no-op. And I didn't see anything. Did I type that correctly? No, I didn't. All right, again. There we go. We got our no-op on the UART. Okay, so let me jump to another thing real quick. Because I did go through all this trouble creating this little app I call Blinky. And I'm going to send a command to turn an LED on. Let's say LED 5. You can see there that it's on. And LED 6 on. I had some telemetry pages too, but I think I'm going to run out of time here. So I think I'll call it a demo there. And, of course, you're willing to grab a BeagleBone board and download my repository and follow the directions. You can get all of this up and running on yours too. So with that, I will stop sharing my screen and either take questions on Slack if there's no time available.
Yeah, Alan, unfortunately, I mean, that was a really fantastic demo. Unfortunately, we don't have any time for questions. I think we'll move a lot of it over to the Slack. So thanks so much.
Okay, sounds great. Thanks a lot.